So one of the big ideas in calculus is this idea of knowing what the parent function is doing without being able to see the parent function doing it. Okay? Being able to predict where are the maxes and mins in the parent function. Where does the parent function have a slope of 0? Where is the slope negative? Where is it positive? Where is the parent function concave down? Where is the parent function concave up? These are the big ideas we're going to be talking about for the next couple weeks. All right, it's a pretty big topic right here. It's the idea of extrema. So I've got on the picture on the right-hand side here, the parent function is this one right here. This is the parent. That is your f of x. And graphed right next to that is the derivative, the f prime. So this one here is your f prime. So a couple things I'll point out right off the bat. When the slope is 0 on the parent function, we have a relative min or max. Can you agree with that? Slope is 0 right there. I have a hump, that's a relative max. Down here I have a hump, or a value that's a relative min. Notice what f prime is when that hump occurs. What is f prime?
0.
0.
So that's
right there. Okay? Right there and right there. Those are your two critical points. So we're going to talk a lot about critical points in the next couple of weeks. The idea of finding a critical point is taking the parent function and deriving it and set it equals 0, or finding where it is undefined, where x is on the bottom. That's the two things we're looking for. Those are our critical points. Those are our candidates for maxes and mins. They don't always have to be maxes and mins. Those are our candidates. So you differentiate, you factor the top and bottom if you have a top and a bottom, set them equal to 0 and solve, and if they're doing asymptotes, set the bottom equal to 0 and solve. Does that make sense to you? Okay with that? So that's step one. You're always going to find your critical points. These other ones, it just depends on the question. Step 2 through 5 is, what's the question asking me to do? Is it asking me to find absolute extrema? If it is, then do what I'm about to tell you. Okay? So absolute extrema would happen if you had endpoints. So if these graphs didn't go on forever, what if this graph stopped here and stopped there? Okay? Those would be the endpoints. Let's call this the endpoints from, oh, I don't know, let's just say it was from -1 to 4. Okay? I'm just making stuff up here. Notice the endpoints are boxed, right? That means they're inclusive. That means I can talk about absolute extrema, because I can include those endpoints. So I would find my critical numbers, find where the derivative crosses the x-axis, plug those x coordinates in to the parent function to get the y values. Do the same thing at the endpoints. So let's give an example. What if the equation was, oh, let's say f of x equal to, I'm trying to find one that's kind of similar here. Y equals to x cubed minus 5x squared plus, let's just try that and see if that goes on first. Okay, that's close. We go ahead and give this a plus 4. Okay, so that's pretty close what we got right there. What's going on here? Why are you giving me an error? had x cubed what? Plus 5x squared plus 5, is that what I had?
I think it was minus 5x.
Thank you. Okay, so that's pretty close what we're looking at right here. And so if I'm looking at, I'd like to shift this to the right one. Minus 2x. Having a hard time. Now, it's gonna have to be close enough.
20 feet, 52 K is a minute.
Okay. All right, so if I am trying to find my critical points, I need the derivative of this, don't I? What is the derivative of that guy going to be? If f of x equals to x cubed minus 5x squared plus 2x plus 5, f prime of x is going to equal to
3x squared
3x squared minus
minus 10x.
plus 2. I'm going to set it equal to 0. So 0 equals to 3x squared minus 10x plus 2. Go grab a calculator, please. That way you have it with your hands. You can practice some skills.
Well, I know, I see what you're doing now.
I don't. I'm doing it all along.
I see what you're doing. Oh, yeah.
3x squared minus 10x plus 2.
You can't factor this bad boy.
Yeah, you can't factor that one.
Can't factor this. Do it. What's this decimal is?
Yeah, we're gonna have to. Okay. I'm gonna put a 0 right here on the bottom. Right there. Find where it crosses the x-axis at. I'm trying to find where f prime is 0. I'm not graphing f right now. I've turned f off. You guys know how to do that? Hit enter on the equal sign right there, it turns f off. If it's not black, it's not going to graph it. Okay? So here's f prime. I'm going to graph f prime. Here's 0. I'm going to graph that and find where it crosses the x-axis. So it crosses at that point and that point. Second trace intersect. Enter, enter, enter. At point 2. We'll say point 2 for right now. Okay? And my critical point is point 2, and the other one is second trace intersect, enter, enter, scroll over the right hand side. 3.1.
Will we normally have a calculator to do this? Or will we...
Depends on the problem. Okay, we'll have some with calculator, some without calculator. These problems span both sets. All right, is everybody okay with that so far? Let me bring the parent function back into view so we can see if that makes sense what's going on here. Here's the parent function right here. What do you suppose the slope is right there? For that parent function. Slope is 0 right there, right? At point 2 approximately, my slope right there is going to be a slope of 0. That horizontal line right there, okay? At 3.1, my slope right there is going to be a slope of 0. That's the parent function, okay? And we know that because when we graph the derivative, that's where it crossed the x-axis at. It has a slope of 0 at this point. Remember, the derivative is a graph of all the slope values, right? The slope when x is -1 is a big number. The slope when x is about 2 is 0. Or sorry, is a big negative number. Slope when x is 4 is a big positive number. These are a graph of the slope values of the parent. Are you okay with that? Okay. And so if I want to know the absolute extreme, I need to evaluate these 2 points in f. I'm going to turn the f back on. I'm going to turn off the derivative. I'm going to turn off 0. So all I'm graphing is the parent now. trace 0.2. Okay. So when x is 0.2, f of 0.2 is equal to 5.2. Do you agree with that? Make sense to you? Karen, pay attention? You sure? I don't think you were. Okay? F of 3.1, right, the parent function. I'm just looking at, these are my critical x values in the parent function. Negative 7.1, we'll say approximately. So that's a relative max, that's a relative min. Do you agree with that? Are you following me? The question was, is it an absolute max or min? To check the absolute, I need to check the original bounds that I gave you. So I also need to check f of -1 and f of 4. What is f of -1? Trace -1, that's a -3. And trace 4, that's an f of -3. So we can see that my absolute max is at what? X equal to 0.4, which was about a y value of 5.2, and our absolute min
-7.
was at x equal to 3.1, which is a -7. Those are our absolute maxes and mins. How does that make sense so far? You guys okay with that?
Yes.
Derive. Find your critical points. Evaluate f at those critical points. John, you okay with that? You sure?
And so, if,
Johnny thinks,
I mean, I guess obviously,
he guesses obviously.
if one of those points turned out to be like,
What if this one been -10?
right, then that would have been the absolute.
Absolute min.
Yeah.
Okay.
Even though it's not a,
Even though it's not a hump, right? It could have been a graph went, like if I had done trace -2, if I give you -2 to +4, -2 is a y value of -27. So that would be your absolute min.
what'd you say it was called again when they give you no balance? When they don't give you balance?
So relative min, relative max versus absolute min max.
That's relative.
Yeah, relative. You don't have fixed
Usually that'll
bounds.
be like infinity or something.
Yeah. So you would never talk about that. You just be talking about the relative, the humps in the middle. Okay? All right, let's do one more thing here, and then I'm going to do these first three today and call it good for the day. Okay? Step 3 right here is the idea of increasing and decreasing. Where is the parent function increasing? Where is it decreasing? We still have to use our critical points. We'll be doing this over and over and over again. You're going to derive z equal to 0. You okay with that? So let's go back to the example I gave you, right? Let's go back to this picture right here. That way you can look at this picture and see what I'm talking about. All right? I derived it. Its critical points are, we're going to say, at 1 and 3. You okay with that? That picture right there? So the question is, where is the red graph increasing? Where is it decreasing? What are the intervals of which this happens? Okay? So you do your critical points. We're going to say this graph up here is x equal to 1 and 3 on my critical points. We're going to pick a test value out of each of those intervals and ask the question, is f prime positive or negative in those intervals? So this is a graph you're going to draw a bunch. You're going to draw a horizontal line. You're going to put all your critical points on here. You're going to pick numbers that are in the interval. So So what is a number left of 1?
Zero.
0, okay? So I like to write those actually on the line. That's the number I'm evaluating at. What is the number between 1 and 3?
2.
What's the number bigger than 3? 4, okay? So we're going to look at f prime and ask the question, what is the sign of f prime at 0? So f prime is the black line right here. What is the sign of f prime at 0?
Oh, negative.
No, the y value is a positive number. Yes, it's going down, but it is a positive number. Remember, f prime is the y, all the y values are these slopes. This is a positive slope. So that means left of 1, the parent function is increasing. Here's the parent function in red right here. It is increasing until we get to an x value of 1. Let's pick a number between 1 and 3. We pick 2. Okay. So what is the, here is the, here's f prime right here. That is what kind of number right there, positive or negative? The y coordinate of that. That's approximately, we're going to say it's approximately -1, right? Follow me? The derivative graph has a y value is negative right now. That means the slope of the parent is a negative number. The parent function is decreasing from here to here. It's going down. It has a negative slope from here to here. And then pick a number bigger than 3. So we'll pick 4 right here. Okay. The y coordinate of this derivative graph is a positive number. So therefore the parent is increasing again. So it is decreasing from 1 to 3. And it's increasing from negative infinity to 1 and from 3 to infinity.
So we don't use brackets on these?
What's that?
We don't use brackets, we just use.
Never use brackets on increasing or decreasing. Because when you get to the critical point, that's a slope of 0 right there. Am I increasing here or decreasing here?
Neither.
Neither. I'm on top of the hill. I'm neither going up nor going down. Therefore, we'll never use brackets on increasing or decreasing. Okay? All right, we'll do step 4 and step 5 tomorrow if I'm here, on Thursday if I'm not. I'm going to be here tomorrow. Okay, we'll see. But I think I've given you enough to get through tomorrow's homework, even if I'm not here.